RHS Pre-Calculus presents Flight 1394, a lesson in aviation trigonometry.
Final call for Flight 1394 to Tokyo, non-stop from Seattle.
Thank you for flying Air Keeler today. Please make sure your seat belts are fastened and all trays are locked in the upright position. We hope you have a good flight.
I have to say, I'm a little nervous. This is my first flight after my license, and what if you were to get hurt? How would I know where to go?
It's easy. Here, let me show you. First, some basics. On an aviation graph, 0 degrees is the upper vertical axis here. This is also north.
Oh, so south is down here at 180 degrees.
That's right. Also, an airplane's course or heading always heads away from the origin, or center, and wind direction is always towards the origin.
But what's the course? Is it the same as the heading?
Only if there is no wind, or wind directly behind or ahead of a plane.
What?
The heading is the direction a plane tries to travel to compensate for wind. The course is the direction a plane actually travels.
Oh, I get it now. But how do you figure out what they are?
Well, first we have to fill out the information we know. If you don't know your heading or your course, you won't be able to figure out how to get there. You need to know one or the other. So we know that Tokyo is at 300 degrees. We also know that we need to travel at 476 miles per hour to get there on time.
How does the wind affect us? It's blowing at 15 miles per hour from the south.
Well, south is 180 degrees, so we draw the wind moving towards the origin. However, we can't calculate anything if they meet at the origin. Instead, we draw a parallel line at the end of the line for our course. Now we have to decide where to draw in our approximate heading. Since the wind is coming from the south, we want to draw our line to the south, all the way out to the wind line.
So if the wind was coming from the east, we would draw the heading to the east?
Exactly. Now we know that if we extended our course line here, it would make a 120-degree angle with the wind line. Because the line is 180 degrees, the angle here is 60 degrees. Now we can use the law of cosines to come up with the measure of the other side, which is the same as the speed we will have to travel. The law of cosines says that a squared plus b squared minus 2ab cosine of angle c equals c squared. When we plug in our numbers, we get that c is 468.96 miles per hour.
Wow, that's the speed we're traveling now.
Exactly. Now that we have c, we can use the law of sines to find the angle of difference between the course and the heading. The law of sines says that sine of angle a divided by a equals sine of angle c divided by c. When you cross multiply using our numbers, we get that sine of angle a equals 0.0277. When we solve for angle a, we get 1.587 degrees.
But how does that help us?
We can subtract 1.587 degrees from 300 degrees, which will give us our heading.
So we need to travel at 298.413 degrees?
That's right. There, now you know how to figure out your heading from your course.
But what about figuring out your course from your heading? I still don't know how to do that.
Why, it's easy. All you have to do is draw the line for the approximate course on the opposite side of where the approximate heading would be, and solve it the same way.
Thank you so much. Now, if you were to be incapacitated, I'd be able to fly the plane where we need to go.
Flight 1394, you're nearing Tokyo for airspace. Prepare for landing instructions.
Well, it was fun flying with you. Remember everything I told you, and you'll do just fine.
Okay, I will.